going to take a look at section 5.2 this time. And this is going to be that we are looking at other ways to solve systems of equations. Now, this section, we're going to focus on matrix solutions. Okay? And we are going to specifically talk about the Gauss-Jordan method of doing a matrix. Now, y'all should slightly remember matrices from Algebra 2. Should be the one that you remember this from. And so when we go to set these up, okay, and we're going to look at an augmented matrix. So what I'm going to do is I'm going to put the system up here. Okay, and so what's going to happen is we're going to make what's called an augmented matrix, okay, and we're going to put the coefficients only on our variables, and then I draw a line right here, okay, that represents my equal sign. So we have x, y, z, and then our answer value. So that means that our equations need to have x, y, z all on one side, the answer on the other, and they do need to be in that order x, y, z. So 2, 1, negative 1. For that, subtract z, and that equals 2. And then we have 1, 1, 1, and 2 for that last equation. Okay? Now, when we talk about this, the size of this, it is always the number of rows first, and then the number of columns. So this would be a 3 by 4 matrix. Okay? Because this is rows and then columns when this happens. Okay? Now, in order to solve this, okay, the goal is to make this matrix look something like this. Okay, now the nice thing about this is if I have one x, no y's, and no z's, that means x equals A, whatever that is. Here I have no x's, one y, and no z's, so I have y equals B. Here I have no x's, no y's, one z, so z equals C. Now, how do I get from here to here? Okay, well, what we do, okay, is there are 3 things that you are allowed to do within a matrix. Okay, so first option is you can switch any 2 rows. Okay, so any 2 rows that you want to switch. Okay, second one is you can multiply / divide any row by a non-zero number. So no multiplying or dividing by 0. Okay, and then the third thing is you can multiply any row and add it to another row as a replacement. Okay, so now the method that we go about trying to do this, okay, is we start by trying to get a 1 in that top corner, and then we're going to use row 1 to get zeros to happen underneath it, okay? So we are going to use row 1 to make these zeros happen. Then you're going to get a 1 in the middle, and you're going to use row 2 to make zeros above and below. Now, the reason you want to do this is where we're going to use that multiply any row and tack it on. Anything times 0 plus 1 is still going to give me the 1, and anything times 0 plus any zeros here. So it's very key that we do this. Then we're going to get a 1 in that bottom corner, and we're going to use row 3, okay, and this is the notation, R with a little subscript, to make the zeros happen above it. And then we're going to have a solution, okay? Now, we do not normally use these on 2x2 systems. I'll show one with a 2x2 just so that you see it, but generally 2x2 systems we use, or we do substitution or elimination over in one of the other setups to make this happen. So, but I'm going to show one because it may come up and they ask you for it. Okay. So first thing I'm going to do is I'm going to make my matrix. Okay. So first thing that I'm going to do is row 1 divided by 3. Okay, because I'm trying to make a 1 up here, and the easiest way to do that is to just divide by 3. So it's going to be 1 negative 4/3 1/3, and I am going to keep this stuff in fractions. 5, 2, and 19. Okay, now I need to get rid of this 5. So I'm going to use row 1. So I'm going to multiply row 1 with something to clear this off. So to get rid of a 5, I need a negative 5. So notation for this is going to be negative 5 row 1 plus row 2, and that's going to be my new row 2. Now, when I do this math, okay, guys, I never try to do all this math like straight in my head or anything like that. So I'm going to write down what that is here. So that is going to be negative 5 20/3 and negative 5/3. And then I'm going to have 5, 2, and 19. And I'm going to add these together. So it's going to be 0. Let's see. That's going to be, instead of 2, that's going to be 6/3. So that's going to be 26/3. It's going to be a great number. And instead of 19, that'll be 57/3. Okay, that's great. And so adding those, I get 52/3. It's great. Okay, it'll clean up in this next line, I promise. So now I have 1 negative 4/3 1/3, 0 26/3 52/3. Okay, now I now have my 0 here. I need this to be a 1. Guys, I'm going to multiply by the reciprocal, okay, to clean this up. So now I've got 1 negative 4/3 1/3, 0. That's going to turn to 1, and then 52/3 times 3/26 gives me 2. Oh, it cleaned up pretty, didn't it? Okay, now, hang on, I gotta move my setup over here just a little bit so I can get some more space. There we go. All right, now, this is just a rewrite, okay, guys? I'm not changing anything. Okay, so now what we're gonna do, I need a little bit more space, but oh well. Okay, I need to use this one to get rid of that. Okay, so I'm gonna just mark this down here. I'm gonna do 4/3 row 2 plus row 1. Okay, and that's gonna be my new row 1. So that's gonna give me, so top row isn't changing. Bottom row is gonna be 0, 4/3, 8/3. We're gonna add that up. So it's gonna be 1, 0, and 9/3, which is going to be 3. So now, rewriting my rows, I've got 1, 0, 9/3 is 3, 0, 1, 2. Okay, so I have X and no Y, so that means X equals 3, and no X's and 1 Y means Y equals 2. Now, personally, I think there's more involved in this. Okay, if you're going to do it with a matrix. Now, for a 2x2 system. Now, when we get up into a 3x3 system, that is where the advantage is going to come into play for this stuff happening. Okay, so let's take a look at a 3x3. Okay, and see where this is going to go. Okay, now I will say that on a 3x3, this is probably going to get, it gets kind of lengthy, okay, just because we are going to have to do so many little matrices, okay? So I'm going to write my system up here first. And I've switched to a thinner marker, hoping that I can get some of this to fit a little better on this dry erase board. Okay, so here we go into our starter matrix. 1, -1, 5, -6, 3, 3, -1, 10, 1, 3, 2, 5. Okay, so I've already got a 1 right here. So I'm going to start with -3 row 1 plus row 2, and that's going to be my new row 2. Okay. So writing my stuff down, that's going to be -3, 3, -15, 18, 3, 3, -1, 10. It's going to be 0, 6, -16, and 28. So I've got 1, -1, 5, -6, 0, 6, -16, 28, 1, 3, 2, 5. Okay. Now, I just need a -1, so negative row 1 plus row 3. And that's going to be my new row 3. So it'll be -1, 1, -5, 6, 1, 3, 2, 5. 0, 4, -3, 11. So we've got 1, -1, 5, -6. Sorry, I'll keep moving down here a little bit. Try and keep all this nice and pretty and square. 0, 6, -16, 28. And then 0, 4, -3, 11. Okay, so now I need to make this middle spot a 1. So I'm going to do row 2 divided by 6. So it's 1, -1, 5, -6, 0, 1. Now, -16 over 6 is going to be -8 thirds. And then 28 divided by 6 is going to be 14 thirds. Okay. So 0, 4, -3, 11. Now then, I'm going to go ahead and make the 0 happen above here. Okay. Because that's pretty straightforward. It's just going to be add. So I'm going to do row 1 plus row 2 replaces row 1. So it's going to be 1, -1, 5, -6, 0, 1, -8 thirds, 14 thirds. Okay. And that's going to give me 1, 0, 7 thirds. Okay. And then excuse me, -4 thirds. Okay. I'm going to go ahead and move up and write that new matrix up here. Okay, so now I'm going to use this 1 to get rid of this 4. So -4 row 2 plus row 3. And that's going to replace row 3. So I've got 0, -4. -32 thirds. -56 thirds. 0, 4, -3, 11. It's 23 thirds. negative 23 thirds. So now we've got 1, 0, 7 thirds, negative 4 thirds. Um, 0, 1, negative 8 thirds, 14 thirds, 0, 0, 23 thirds, negative 23 thirds. Hopefully, guys, you're seeing that that's going to be really pretty. I'm going to do 3 20-thirds. I'm going to multiply by the reciprocal, row 3. So that's going to give me 1, 0, 0, 7 thirds, negative 8 thirds, 1, negative 4 thirds, 14 thirds, negative 1. Okay. So now I'm going to use this to help clear these other ones. So I'm going to do negative 7 thirds, row 3, plus row 1. So it's going to be top row, and then leave that. That's going to be 0, 0, negative 7 thirds, positive 7 thirds. So 1, 0, 0, 3 thirds. That's all of a sudden pretty. 1, 0, 0, 0, 1, 0, 0, 1, but negative 8 thirds and 14 thirds, that's still sitting, and 1 and negative 1. Okay, and then I'm going to do 8 thirds row 2 plus, or sorry, 8 thirds row 3 plus row 2. Okay, so again, the math with that: 0, 1, negative 8 thirds, 14 thirds, 0, 0, 8 thirds, negative 8 thirds, 0, 1, 0, and that is 6 thirds. So I've got 1, 0, 0, 1. Down. 0, 1, 0, 6 thirds is 2, 0, 0, 1, negative 1. Okay, so x is 1, y is 2, z is negative 1. Okay. Okay. Now, you can still get infinitely many or no solution with these. Okay. Now, the infinitely minis and the no solutions are pretty straightforward when they're going to show up. Okay. So what's going to happen, and this can happen anywhere in the matrix. Okay. But what's going to happen is in your matrix, if you get, and it doesn't matter if it's 2 zeros or 3 zeros, I'm going to show it with 3 zeros here, and you get a number over here. Okay, so if 0, 0, 0, and then a number shows up, this is automatically no solution. Okay, this is like when we did the elimination stuff and we got 0 on the left equal 15 on the right. That can't happen, so this is no solution. Now, if you get a zeros all the way across, this is your infinitely many. Okay, so it looks very, very similar to how it looked in the, when we did the elimination stuff. It's just now done in, the matrix format where you don't have all the X's and Y's, okay? I know that this section may be a little bit more of a challenge because of all those little inner steps, okay? Just watch what you're doing very, very carefully as you're processing through that, and hopefully it won't be too terrible.